These are ashes. This used to be a beautiful green landscape, but now it's burned out. Hey, I'm Marta and I'm from Portugal. In the last 20 years, Portugal has lost around 400,000 hectares of green area due to wildfires. But it is not just here. In the whole world, an annual average of 70,000 wildfires have burned an average of 7.4 million acres since the year 2000. That, among agriculture expansion, wood extraction and infrastructure expansion, is causing around 10% of global warming. There's simply no way we can fight climate crisis if we don't stop deforestation. Trees are vital. They give us oxygen, store carbon, stabilize the soil and give home to the world's wildlife. The United Nations set the famous sustainable goals to prevent climate crisis. One of its goals, the Goal 15, aims to preserve life on land. Two of its targets aims to end deforestation and desertification and restore degraded lands and forests. To tackle reforestation, we have a lot of projected machinery and human volunteers to restore the so missed trees. But the goal hasn't yet been achieved. We know by the 2023 tree planting statistics that in the entire world, an average of 500 trees are cut per second, but only 60 are planted. So that's not enough. But the main reasons why reforestation is not being achieved, except for the bad forest management, is because human labor and human volunteering brings a lot of challenges in terms of injuries, maintenance and capability. Also, 30% of the Earth's surface is compounded by rough terrain, mountains and cliffs. Therefore, it's totally risky to send human volunteers out there and to navigate with machinery as well. Disturbed with that information, I invented Trovador. A tree planting robot with the capacity of accelerating the reforestation process and restore green ecosystems.
Trovador is an hexapod robot that carries newborn trees the length of a bottle and comes as a response to replace human volunteering and machinery work.
To build Trovador, I focused on two things: the outdoor locomotion and the tree survival rate.
Trovador walks on optimized planting sequences. These sequences begin with a 5-meter walking pattern using a tripod gait, which means it walks with a suspension of 3 legs at a time in order to move more efficiently. Then, the robot takes the tree from the holders and sticks its gripper on the ground. Here, the implemented humidity sensor on the gripper measures the pH levels of the soil and determines whether it leaves the tree there or not.
If the pH level isn't high enough, the robot walks 2.5 meters forward and does the same pH measuring again. And does this until the humidity of the soil is nutritious enough to grow a tree on.
Because this process is automated, the trees are planted on the right depth, and thanks to the humidity sensor, the survival rate of the trees increases gigantically. When the pH level measured meets the perfect conditions, the gripper leaves the tree there and repeats the sequence, but now with the leg on the other side. Whenever the tree is planted and the robot moves forward, the back leg makes pressure nearby the root collar to ensure the roots are tight enough with the soil. This is only possible because the robot is walking on a tripod gait. Measuring the distance between those trees planted on a 5-meter distance in length and 1 meter in width, the hypotenuse of 5 meters is equal to the minimum distance to plant 2 trees, optimizing the planting process. Throughout the entire sequence, the robot maintains its balance, allowing the locomotion to be stable on rough terrain.
This is only possible because the robot uses a PID controller implemented on the software. This is super important because on the outside there are plenty of obstacles to face, and while carrying a numerous amount of trees, it is crucial to have the center of mass stable. The version I built is an alpha version, which is 4 times the size of a computer. It was built with a budget of 15 euros and recycled materials. But to achieve the challenge I'm running to, its ideal size would be 4 times its current size to fit around 300 trees and plant them in 1 hour. Future steps of Trovador will be the implementation of reinforcement learning to improve the tree planting sequence and, most importantly, the balancing controller. Another huge improvement will be the implementation of real-sense depth camera to use stereo vision to calculate depth and overcome the surrounding obstacles more easily. For more technical depth, read Trovador, a tree planting robot, the robot's technical article on Medium, and please like and share this video to help this mission reach to more people. Let's replant our home and have green landscapes again. See ya!